Welcome everyone. Today we are going to discuss a SuMON problem. This problem is based on game theory and it exemplifies one of the major milestones of SuMON. We want students to engage in game theory type problems which is unconventional in the competitive society that we are living in. Let me give you an example through the fortnight 38 of level 3 problem. Here's the problem. It's very simple. Two players play a game alternatively taking 1, 2 or 3 coins from a pile of 21 coins. Now the player who takes the last coin wins the game because the next player will not have any move. Prove that the first player has a winning strategy, can force a win. All these are the same. So they can play strategically in order to win this game. Let's see how this is possible. Whenever you tackle such problems, you have to break down into smaller parts and reach the conclusion by building upon them. Instead of handling with 21 coins, what if you have only one coin? The first player who plays the game will take out that coin and they will win. So here we are assuming two players, player 1 and player 2. So if there is only one coin, player 1 wins the game. So I'm going to write that here. Who wins in the second column and number of coins in the first column. Alright, now take some time to build on this idea and reach the conclusion with 21 coins. Take at least 10 minutes to 45 minutes to devise a strategy for this solution. We will get started soon. Alright, here for 2 coins, again the player 1 can remove those 2. If there were 3 coins, then player 1 again wins the game by removing all 3. But for 4 coins, player 1 cannot remove all 4 as only 3 or 2 or 1 is allowed. So whatever they perform, by removing that, they will be pushed to a configuration in which it favors the player 1. But what does that mean? Player 1 is the player who encounters that configuration for the first time. When player 1 removes the 4, removes some coins from 4 and give it to player 2, then actually player 2 is the first one to encounter that configuration with less than 4 number of coins. And therefore, player 2 will have the winning strategy now. You see, over here, when there were 2 coins, player 1 won because they were the first person to encounter those coins. Now going from 4, you can only reach 1, 2 or 3 in which the first player to encounter it wins the game or has a winning strategy. Now when player 1 removes some coins from 4 and give it to the second player, player 2, then they will be the first one to encounter that configuration or the number of coins which is less than 4. So therefore, they will have the winning strategy now. That's how you induct upon the solution. This is like induction, but you have to go through step by step to understand how it works. So kind of game theoretical induction. Alright, now if there were 5 coins, then player 1 will just remove 1 coin and give it to the second player. And now player 1 is the second player to encounter those configurations. Therefore, player 1 will win the game. Hence, reaching from 5 to 4 favors player 1. Because then player 1 will become the second person to encounter those many coins. That is 4 number of coins. And 4 coins favors the second player to encounter it. Hence, first player wins the game here. So, first player will have 5 coins. They will remove 1 and give it to second player, which is 4 in number. And the 4 favors the second person to encounter it, which is player 1. That's how it works. And with the same logic, for 6, player 1 will win by moving it to 4 number of coins. For 7 again, player 1 will win by moving it to 4 number of coins. From 8, you can only go to these 3 configurations, 5, 6 or 7, which will favor the first player to encounter it, and that is P2. So therefore, P2 will have winning strategy. So by this repetitive argument, we get that player 2 has a winning strategy if and only if the number of coins at the start is a multiple of 4. And as you proceed up to 20, player 2 will have a winning strategy, and for 21, the first player will have the winning strategy. This means the player 1 will remove 1 coin and give it to player 2, and then player 2 will take it to one of 17, 18 or 19, and then player 1 will remove the number of coins so that it gets back to a multiple of 4. So this is like always player 1 is ensuring that the number of coins after their move is always a multiple of 4, which is given to the player 2. And player 2 will have a bad time with the number of coins being multiple of 4. So therefore the other player will win the game, hence the first player has a winning strategy that way. So that's how you make it an algorithm and prove it in this way. There are several other problems related to game theory in our sessions. We try to make some strategic puzzles. We also give Ken puzzles sometimes. And the main motive of our worksheet is that we want students to engage in some unconventional mathematical logical thinking. We don't want students to do just routine formula applications and come with an answer. So this is about their own way to devise a strategy. Maybe they can find some other strategy for this question. This is just one of our solutions. In fact, we send out solutions only after 14 days of time. So they have ample amount of time by that. If you are interested in joining to our program, you may subscribe through a free trial worksheet at www.sumonmath.com. See you soon, everyone. Bye.